Okay, so we've been talking about the forces that allow substances to stay in a particular state, whether it's solid, liquid, or gas. And we've discussed how there's a constant battle between kinetic energy or the motion of moving particles, kind of pulling particles apart, and intermolecular attractions or attractions between molecules holding those molecules close. And we discussed the fact that in a solid, the intermolecular attractions are the largest as compared to liquids and gases, and the kinetic energy is the least. Whereas as we move from liquid to gas, once we get to gas, the intermolecular attractions or the attractions between the molecules holding them together is almost non existent, and the kinetic energy is the greatest. So, today we're going to be talking about the concept of surface tension, which is related to intermolecular attractions or those attractions that tend to hold molecules together. So, remember that within each state of matter, there are two opposing forces: kinetic energy, which is the energy of a mass in motion. Okay, that tends to pull molecules apart from one another, and IMAs, or intermolecular attractions, which is an attractive force that tends to hold those molecules together. So you're going to need to be filling in these notes as I fill them in, and then you'll submit that for a grade. So remember, we have this constant battle between kinetic energy trying to pull molecules apart and attractions between the molecules, or intermolecular attractions, trying to hold them together, with the kinetic energy being the largest in a gas, smallest in a solid, and the intermolecular attractions being the strongest in a solid and the weakest to almost non-existent in a gas. So kinetic energy tends to pull molecules apart because they're in motion. They want to move away from each other. And intermolecular attractions tends to draw those molecules together. Okay, so there's a battle between those two opposing forces. Okay, a chemical bond, so a little bit of review here. A chemical bond is a force of attraction that holds atoms together in a molecule, like the types of attractive forces that hold hydrogen atoms and oxygen atoms together in a molecule of water. At the beginning of the year, we modeled atoms with marshmallows and chemical bonds with toothpicks, but we want to talk a little bit more now about what exactly are those chemical bonds. So remember, we designated a particular marshmallow color to be a hydrogen atom and a different color to be an oxygen atom. So the marshmallows represent different atoms, and the toothpicks were used to hold these atoms together and represent chemical bonds that hold atoms together in a molecule, like this molecule of water. So a chemical bond is formed in one of two ways, okay? So a chemical bond is formed when atoms share electrons, and this type of bond is called a covalent bond. So when we talk about like co-workers, those are workers that are working together. Those would be like teachers in the same building, or you when you're working with a group. When atoms of different elements share electrons together and form that type of chemical bond, it's called a covalent chemical bond. But sometimes the atoms don't share electrons. Sometimes the atoms steal or give away electrons. And this type of bond is called an ionic bond, because when you get extra electrons by stealing electrons, or you give away your electrons, you become charged, and a charged atom is called an ion. So we're not going to be dealing with ionic chemical bonds. We're going to be focusing on covalent bonds, where atoms share electrons. So sometimes a particular atom, and the one we're going to focus on is oxygen in a water molecule, tends to hold tighter to the electrons than the other atoms. It's much like a child who's sharing their toy, but one child is spending more time with the toy than the other child is. So there's a sharing there between the two children, but one child is hogging the toy and getting more time with the toy. In this way, the oxygen atom in a water molecule is sharing electrons with a hydrogen atom, but the electrons are spending more time with the oxygen atom with the hydrogen atom. And because electrons are negatively charged, this gives one end of the water molecule, specifically the oxygen end, a slight negative charge. And because the oxygen atom is pulling those electrons away from the hydrogen atoms, the hydrogen atom end of the water molecule is going to have a slight positive charge. So sometimes a particular atom holds electrons tighter than other atoms when the two are covalently bonded or sharing electrons. This causes an unequal sharing of the electrons, which again are negatively charged particles. And as a result, the ends of the molecule become charged. A charged molecule is said to be polar. And the reason we call it polar is, think about the Earth, how there's a North Pole and a South Pole. So you have one end that's called a pole and another end that's called a pole, or a magnet where you have the North Pole and the South Pole. We're doing the same thing with molecules. The end that is negatively charged and the end that is positively charged, we would call them the negative pole and the positive pole. So the molecule is polar because it's got these charged ends to it. Okay, because the water molecule is charged or polar, it tends to stick to other water molecules, as you can see in this diagram. So the negative end of one water molecule is attracted to the positive end of another water molecule, and so on. This happens because opposite charges attract. The attraction between molecules and their tendency to stick together is called cohesion. Okay, so the oxygen end of a water molecule has a negatively charged end and a positive end. This means water's net charge is spread out unevenly, and we call that polarity. Okay, and then this side just says the oxygen end of one water molecule sticks to the hydrogen end of another water molecule because the positive and negative ends attract. So why does water beat up at the surface and also form a thin elastic film? Okay, surface tension, and you do need to get familiar with these terms: cohesion, polarity, surface tension, is a phenomenon in which the surface of a liquid, where the liquid is in contact with a gas like the surrounding air, acts like a thin elastic sheet. It does this because the water molecules at the surface are polar or charged and are being pulled at the sides and from below by other charged water molecules. So you can see here a droplet of water, and we're focusing in on the individual water molecules that make it up. So the water molecules beneath the surface are pulled in all directions. So this molecule is attracted to this one, or repelled, and there's forces acting on all sides. The molecules at the surface, however, are all pulled together and inward because they're attracted to the molecules beneath the surface. They're not very attracted to the air molecules. And so because of this, it creates this inward pulling that forms the droplet. So surface tension, or the thin elastic cover formed at a liquid surface, is the result of intermolecular attractions. Okay? So when we're constantly talking about kinetic energy pulling molecules apart and intermolecular attractions, or attractions between molecules, pulling those molecules together to hold a particular state of matter in that state, one example, a visual example of these intermolecular attractions, is surface tension.